for coming. My name is Zhixuan, and I'm a software engineer at Tinder. So earlier this year, our backend transitioned to WebSocket for our real-time features such as chat. And as we took on the challenge to integrate WebSocket on Android, we found the existing solutions difficult to set up and maintain. To make WebSocket integration easier on Android, we created Scarlet, a declarative Kotlin library that lets you build a production-ready WebSocket client in just 10 lines of code. And how many of you have used WebSocket before? Oh, that's a lot. That's great. So WebSocket is a well-established client-server protocol, and it supports text and binary messages. It's real-time, meaning that messages are delivered instantly. It's efficient because it has low overhead. And it's also bidirectional. Not only can the client send messages to the server can also stream messages down to the client. And let's see it in action. This is how you would create a WebSocket connection in JavaScript. And you can listen to when the connection is open and send a message to the server. Of course, you can also listen to the messages sent from the server and process them. This is just a simple example of how WebSocket can be used. And here's a list of real-time applications that can really benefit from WebSocket. For example, chat, which we did improve with WebSocket at Tinder, and multiplayer games, where data needs to be synchronized between multiple devices, and real-time feed, such as stock price and traffic information. So WebSocket is powerful, but as mobile developers, we're already familiar with REST APIs, and most of our apps are already built with REST APIs. Why should we care about WebSocket? Is it really better than REST? Let's find out by a real-world example, Bitcoin trading. So suppose each of us are given one Bitcoin, which is worth $7,000 right now. How do we make more money out of it? We can trade Bitcoin. And to make a profit, you need to buy low and sell high. But how do you know when to buy and sell? To make such a decision, you need to gather as much information as possible, including the market movement and the real-time price. Last week, Bitcoin was down in 10% in just an hour because Bitcoin is so volatile. As Bitcoin traders, we need to get the real-time price. And let's build a tool that fetches us the real-time price. And we'll represent each data point using a ticker. A ticker has two fields, time and price. It represents the price of Bitcoin at a certain time. With a sequence of tickers, we can draw a chart like this. And we'll be trading on GDAX. It's owned by Coinbase, one of the largest cryptocurrency exchanges in the US. And we can load the latest ticker using either a REST API or a WebSocket API. We'll compare the two and find out which is better. And let's try the REST API first. How many of you are familiar with Retrofit? Right, so that's great. We use Retrofit at Tinder. It's a declarative HTTP client that takes an interface and generates an implementation. It turns method calls into HTTP requests. To load a ticker from GDAX, you can simply declare a method annotate with the request URL and specify the return value. Notice the ticker is wrapped in the flowable. For those, flowable is a concept in RSjava 2, and if you're not familiar with it, it's just a string of asynchronous values. And let's load the ticker. And because flowable is lazy, you need to subscribe to it to make the request. And let's process the data. And because one request only has one response, you only get one log. And that was easy. We did it in 10 lines of code. How can WebSocket possibly be better than this? Well, the problem with the REST API is it's not real time. You can get the latest Bitcoin price, but you won't know when it's changed. The best you can do is polling. And by polling, I mean fetching tickers repeatedly at a fixed interval. If your interval is too long, like 1 minute, you'll get a delay up to 1 minute. If you want to get more real-time data, you need to narrow the interval down to such as 1 second. But the overheads may add up over time because HTTP requests has headers and other costs. And if you're polling more frequently than the price changes, your request may be wasted because you'll get the same response back twice. So if you want to get real-time data from GDAX, you probably prefer WebSocket over REST because it allows GDAX to push real-time tickers efficiently to your device. But there's one problem. WebSocket is difficult to use on Android. It's difficult to set up. Most existing libraries requires hundreds of lines of code to set up. There will be boilerplate code involved for data serialization, and as developers, we will have to manually open and close the connections and keep track of all the states as when the connection fails and when the app enters background. Because, if we mix all of them together, which we usually do, we will get spaghetti code. And so WebSocket is also difficult to maintain on Android because most libraries only provide a low-level API, and it's very hard to maintain it unless you write very modular code, which takes a lot of effort. Suppose your server API changes and you need to support a new data type, suppose parsing a new data type, you probably need to change a lot of code. And suppose you want to change your JSON parsing library from Moshi to Jackson, you be prepared to rewrite a couple of files. So how can Scarlet help? You can think of it as the retrofit for WebSocket. It makes WebSocket significantly easier on Android. It's easy to set up. Instead of writing hundreds of lines of code, you only need 10 to integrate any WebSocket APIs. And there's no more boilerplate code, and it comes with a lot of built-in plugins that make it compatible with your existing tech stack, whatever the libraries you're using. And it's easy to maintain because everything is declarative and modular. Most importantly, it's reliable because it's been tested at scale at Tinder. It's been in production for 6 months, but we have found 0 issues with it. And let's use Scarlet to integrate GDAX in 10 lines of code. But before I show you the code, let me be aware that a WebSocket API is different from a HTTP or a REST API, which has a request and a response. When you're working with WebSocket, you are sending messages back and forth between the client and the server. In order to receive takers from GDAX, the client will need to send a subscribe message to specify what kind of takers it wants on the connection when the connection is open. Otherwise, the server will not send messages to you. So let's dive right in. Similar to Retrofit, Scarlet also takes interface and generates an implementation. To send this subscribe message to the server, you will need to declare a method and annotate with the send annotation and specify your data type as the only parameter. So the subscribe message looks like this. It will be serialized to JSON using Moshi before it's sent to the server. Because we're interested in the Bitcoin taker, we'll have a subscribe message like this. And after we created an implementation of this interface using Scarlet, you can just send the message to the server. In order to send this message at the right moment when the connection is open, you need to declare another method that listens to that connection open event. It will take a different annotation, receive, and it will have a return type of flowable of events. And you can subscribe to it and send your message. So after we send a subscribe message to the server, we need to listen to takers. And it's similar to an event listener. It has a receive annotation, but the return type will be the data you want. In this case, taker. And let's subscribe to it and process the data. Because the server sends down a sequence of takers, we will receive multiple of them in real time. So let's recap. To integrate GDAX WebSocket API, we declare 3 methods. We then generate an implementation of this interface and add an event listener for the connection open event, and we send the subscribe message when the connection is open. Next, we process the taker by subscribing to the right method. And that's it. It only takes around 10 lines of code, and you'll have a production-ready WebSocket client for GDAX. We've seen how declarative Scarlet is. Let's talk about plugins. In the previous example, we use RS Java and Moshi, but Scarlet is actually independent of those technologies. It uses plugins to support them. We have many built-in plugins, and that makes Scarlet compatible with your existing tech stack, wherever libraries you're using. We plan to support more in the future, and this will cover 90% of the use cases. If you have specific needs, you're empowered to write your own plugins. And if you find anything missing from Scarlet that should have been built in, please let us know or contribute. And if you're starting from scratch like we just did, here's the recommended configuration. The Scarlet builder takes a WebSocket library that is based on, it takes a WebSocketFactory that's based on OKHTTP client. It takes a message adapter factory that uses Moshi that serialize and deserialize your data. It also takes a StreamAdapterFactory that supports RxJava 2. With all the plugins specified, Scarlet will generate an implementation of your interface. If you're not starting from scratch and you have an existing tech stack, let's see how you can configure Scarlet to be compatible with the libraries you're using. So let's start with WebSocketFactory. So this abstraction allows Scarlet to support any WebSocket implementation. We support OKHTTP client. We support mock HTTP server. This is really useful for writing integration tests where you have a server and a client, and the server can be mocked and it can be verified. Or if you want, you can even write your own WebSocket implementation. And in the future, we might support other WebSocket libraries available on Android. So let's talk about message adapter factory. So WebSocket supports both text and binary messages. A message adapter converts messages into data type. For example, in our previous example, we will have an adapter that converts subscribe to JSON and converts JSON back to ticker. And we support Moshi, JSON, and protobuf. We might support Jackson and XML in the future. And let's talk about StreamAdapterFactory. Because the data you receive from the server is a sequence of asynchronous values, we use stream to represent them. We have a built-in stream type. But if you want to use other abstractions, you can specify a StreamAdapterFactory that converts our built-in stream to such as RxJava 2, RxJava 1, or maybe live data in the future, or maybe Java 9 Flow. And of course, Kotlin Coroutine. And just to recap, we've seen how easy it is to set up Scarlet. And once it's set up, you'll be amazed how easy it is to maintain it and support any changes to the API. Let's say we want to support a new type of message called level 2. It looks like this. It provides insights into Bitcoin trading. It represents the order book in real time. It contains bid prices and ask prices. After you declare a data type, a data class that represents the message, it only takes two lines of code to integrate it, like this. If you ever want to, suppose you want to change your WebSocket implementation into a custom one, you can do it in one line of code by just switching the plugin. And if you want to migrate from Moshi to Jackson, it also takes one line of code. It's to switch the plugin. And to support Coroutine, and use sequence instead of flowable, you only need to change 3 lines of code. First, change flowable to sequence, and next, change the StreamAdapterFactory. So Scarlet is easy to set up and maintain. But most importantly, it's reliable. As a library sponsored by Tinder, it's been tested in production all around the world by millions of people every day and running on all kinds of devices. And we have found no issues for the past several months. Before I talk about how Scarlet did it reliably, let's explore the challenges involved with WebSockets on Android, with especially state management. So as developers, we tend to think about the happy path. WebSocket is in our previous example, WebSocket is straightforward because we assume the connection, it will be open and it will stay open. But it's not always the case. A connection may fail. And for example, when you're in a train and that's heading into a tunnel, your connection may terminate at any time. The server sometimes actively terminate your connection to release resources. And when the app enters the background, you might also want to terminate the connection. And when the connection fails, sometimes we want to retry, sometimes we don't. Let's see a couple of scenarios. So in this chart, the horizontal axis is time, and the vertical axis is the connection state. When the user is not in the app, we don't want the connection to be open. When the user opens the app, we want to connect to the server, and the connection state will be on. As long as the user stays in the app, we want to keep the connection open until the user leaves the app. This is the happy path. But what if the connection fails? What should we do? So the connection may fail at any time because of a server crash or because network is unstable. We want to retry because the user is still in the app, and we want to retry until we succeed. So that was actually very complicated because you need to keep track of all kinds of events when the connection, of the connection. But Scarlet has handles retry for you. It takes care of retrying and keeps the connection open. It did it in a very testable way, and all the states are transparent to the outside. And because of this, we were able to have full unit test coverage and integration tests. So what makes Scarlet testable? It's testable because it's driven by a state machine with immutable states. We actually wrote a Kotlin library, a Kotlin DSL for declaring state machines, and it's available as a separate library. And let's demo how the state machine DSL makes Scarlet testable with a simplified example. Let's write a water state machine. We all know that water has 3 states. It can be solid, liquid, and gas, and it can transition between the states. And in order to build a state machine for water, we need to first declare the state. And we use a singleton for each state. And we'll need to declare the transition between them. I will also use singleton for those. And with all the states and events declared, we can build a state machine using this DSL. And first, we specify the initial state, which is solid. When we're in the solid state, and when we receive this unmelted event, we transition to liquid. And when the water is in liquid state, it can become ice, or it can become gas. And of course, when the water is in gas state, it can condense and become liquid. So this is simple and readable, but what's even better, it's testable. After we created the state machine, we can assert its initial value, which is solid. And we can also test the transition. And after the transition, the state will become liquid. And so we just saw how declarative and testable a state machine can be. And here's the state machine that Scarlet uses. This state machine works without any configuration. And what's even better is you can customize it using and configure its behaviors using plugins. So you can customize, you can use the concept of lifecycle to define when the state machine should keep the connection open. And you can specify the backup strategy the state machine uses to retry. And since lifecycle and backup strategies are both plugins, we provide a set of default implementations, such as an Android lifecycle that it's on when the app is in foreground, and it's off when the app is not in foreground. And you can, in addition to this, you can further scope down the lifecycle by combining this with a custom lifecycle. For example, one that represents the user login state. So we have tools that let you declare a lifecycle that is on when the user is logging and off when the user is logged out. If you combine both the app foreground lifecycle and the login lifecycle together, you'll get a lifecycle that's on only when the app is in foreground and the user is logged in. And okay, so we just saw that Scarlet is not only testable and reliable, it's also customizable. And just to recap, it's easy to get started. It has a declarative API and built-in plugins that makes it flexible makes it compatible with any technologies that you're using. It's also customizable for any specific needs. It's easy to maintain because of the declarativeness and the plugin architecture. It's also reliable because we tested thoroughly, and it's also customizable. And yeah, that's all I have. And please try out this library and send us feedback. And I hope this will save you a lot of time when you next time you talk to a WebSocket API. And yeah, please contribute. And do you guys have any questions?
With the state machine library, can I use data classes instead of objects for the state?
Of course, yeah. You can have states that contains data. And yeah, and in addition to states and events, this state machine also models side effects. So you can, when you transition from one state to another, in addition to specifying what the next state should be, you can also specify an action, like a network request, that will trigger more events. Yeah.
So can you tell us a few examples of how you use Scarlet in the Tinder application? Like you only use it for real-time use cases like chat or, I don't know, matching?
Right. We use WebSocket to notify when you get a match and when you get a new message. And we also built a typing indicator on top of it. Yeah. And we're excited for new possibilities that we can add to our app.
Thanks.
Hey, my question is, do you use or can you use any encryption on the WebSocket?
I'm sorry, on the message?
Yeah, so when you're sending or receiving the message, can you use any encryption factory method or?
Do you mean like encrypt the message and then point-to-point encryption?
Yes.
Yeah, definitely. You can write a message adapter factory for that applies your encryption algorithm, and it can also decrypt the message from the server for you. Yeah, it is totally possible.
But nothing default is provided, right?
It's not provided, and it's very easy, I think, to write one. And yeah, if you, I can probably help you write one, like later.
Okay, yeah. Thank you very much.
Mm-hmm.
Hello. As you said, you use the WebSocket for just pushing data to the client. Wouldn't it be considerable to use server-sent events?
Oh, but server-side events, it's only one directional, right? So the server can push data to the client, but the client cannot respond to the server. It has to call a different REST endpoint. Yeah, am I right?
Yes, but you said it is just one directional, the communication with Scarlet.
I'm not sure about the technical details. The difference between them. But I'm happy to discuss after the talk.
Okay.
Yeah.
So I just checked the GitHub project, and I can see that there are 16 commits there. So I assume that the mainline development is not going through that GitHub project. So can you speak a bit more about how do you intend to sync your internal version of Scarlet and the external open source version?
We plan to migrate to the public one. Yeah, well, I think in the future our app will depend on the public repository. Yeah, the public artifact. Yeah, we just make the code public yesterday, and the code is a bit messy, and I will improve it ASAP. Yeah.
So at this stage, do you recommend opening pull requests to the repo?
Of course, yeah, it's identical. Right now, at this moment, it's identical to the one we use internally. And
Great, thanks.
please contribute. Yeah.
So you use Scarlet on backend on Android and also on backend?
So Scarlet is independent of any WebSocket implementation. And it has two built-in it has built-in support for OK HTTP clients, which you can use in your Android app. And it also supports mock HTTP server, which you can use in your test to mock the server. But theoretically, you can write a WebSocket implementation for the server to use on the server side. But I'm not sure if it will be efficient and scalable to high volume because it's not designed to be very efficient.
Okay, so you don't use it on backend in Tinder?
Yeah, we don't use Scarlet on backend. I think we use Node.js on backend. Only for connecting to the clients. We have a lot of edge servers servers that connect, that their only responsibility is to connect to the client.
Okay, so you wouldn't recommend it for backend, the Scarlet?
I guess I have not done it yet. It'll definitely be very useful for prototyping. But if you were to use in the large-scale projects, I'm not sure yet.
Okay.
Yeah.
Thanks.
There's one.
Do you have a version of Scarlet which compiles to JavaScript?
We don't, because we use the Java Reflection API to interpret the interface. But we might be able to do it using annotation processor. I'm not sure.
Okay, thank you.
Hi, I'm not super familiar with WebSockets, so excuse me if my question is a poor quality one, but I saw your interface had two methods, and one was for receiving and one was for sending a message. Can you use one interface for receiving multiple types of messages? So can Scarlet differentiate between them by their types?
So you mean multiple methods that return the same type of data? Am I right?
I mean, for example, if we have one endpoint and you can send two subscriptions to different kinds of subscriptions, and then you receive multiple types of messages. Can Scarlet differentiate between them?
Yeah, so right now, yes, the answer is yes. And I think in one of the examples that I just showed, we receive both tickers and level 2, right? So you can receive, so in one connection, the server can send any type of data to the client. it can send a raw JSON that represents a ticker, or a raw JSON string that represents level 2. And this Scarlet tries to it tries all the possibility, and so it tries different parsers one by one, basically, to determine what the actual data type is.
So is it based on trial and error or something different?
Right. Because you don't have control over. I mean, you don't have. There's no way to know the type. Yeah. But
Okay. So do you advise to create different instances of Scarlet for different subscriptions for efficiency?
So you can have a single data type, such as that. I mean, you can have a wrapper that wraps all kinds of messages, and you only need to declare one method in Scarlet in the interface that represents the wrapper, and it might be, and you can subscribe to it and filter it to distinguish different data types, and you can actually write a message adapter that handles a special message adapter that allows you to declare different data types, and it will handle the wrapper implicitly. So it'll be more readable, but it will be efficient.
Okay, thank you.
Do you have any more questions? Which library? I'm not familiar. So the question is, does Scarlet support Stone? And I'm not familiar with the protocol. And let's discuss offline. And yeah, that's it. Thank you.